So you are going to want to have your technology for you today because I will be showing you how to find the least squares regression line again, even though we did it yesterday on the graphing calculator, and we will use the graphing calculator to give us our answers. Now you want to be careful on test questions for this material because remember, if you fat finger your keyboard and get a wrong answer and you did not show your work, then you are going to lose all marks. So be very, very careful when you're using your technology. Take the extra moment to check that your numbers are correct. So I've even said right here, the problem with drawing a line of best fit by eye is that each person may have a slightly different line of best fit by eye. Instead, you're going to use linear regression. And like I told you yesterday, if you don't like yourself, enjoy regression analysis in college. If you do like yourself, don't do it. Stay away from it. But we use linear regression to generate the least squares regression line. This is the most accurate linear line of fit. Now, our calculators can do other, it's not really a line of fit, curve of fit. We can do other kinds of regression with our calculators. So if you were to do an IA that involved some kind of correlation or something like that, and you were looking for a pattern, realize that a straight line is not always the best model, that there are other options for you. And when you get to IA land, should you want to do that, you let me know, and I'll help you out. For IB math, we stick to linear. So we've been told outright, use technology to find the least squares regression line for the mass on a spring data. And I, because I am going to go over to the graphing calculator, will not be able to see these data points anymore. Grab my handy dandy notes. All right, calculator. So, just like we did last couple times, stat, and then edit. If your lists are populated like mine are already, we need to clear them. So you go up to L1, hit clear, enter, clear list. Do the same thing for L2. Up to L2, clear, enter. Yes, you will have to use your calculator on the next test. And actually, it's a two-part test, so it has a calculator portion and a non-calculator portion. I am not going to ask you to find a line of best fit by eye. It will be use linear regression to find it. So yes, you will have to be able to use a calculator for it. And we just enter the values in. I would use W, weight, as your X's. So just make sure that you type them correctly. 0, 50, 100, 150, 200, 250. Double check. 0, 50, 100, 150, 200, 250. Good. Y values are going to be your lengths. 17.7, 20.4, double checking as I go, 22, 25, 26, at least these were all mostly pretty numbers, and 27.8. Cool, there we are. Also, you always want to make sure that you have the same number of things in L1 and L2, because if they're not the same number of things, I don't think the calculator will give you an error. I think it tries anyway. I'm not quite sure. Great. What are we doing? Using technology to find the least squares regression line. That just means we need the linear regression. So stat, calc. Remember, this is two variable statistics because we have x's and y's changing. Two variable stats. And Katie wants in. All right, come on in, Katie. And hit enter. X list and Y list, they default to L1, L2. Remember, we're not doing any frequencies here. So no frequency lists for this. Morning, Katie. Good to have you on.
Katie?
Yes, Katie. She doesn't feel well, so she stayed home because she's being responsible, but she popped on to Zoom with us.
Oh, I would have spread it.
That's because you're a horrible human being. All right, so you're going to skip over frequency list and go straight to calculate. And I think we got everybody's stat diagnostics turned on yesterday. Oh, crud. Look what you guys let me do it again. You let me do it again. Why? Why? It's not two variable statistics. That's for X bar and Y bar. I'm looking for linear regression, AX plus B. Sorry. Linreg, linear regression, AX plus B, because it's supposed to be a straight line. This is where we needed the stat diagnostics on. It's not necessary, but I'm going to go ahead and store this reg EQ, this equation, as Y1. This way I could graph it if I want, or I could ask the calculator to plug data in for me. It's faster than typing all the decimals. So vars, Y vars, function, y1. There. It is now stored as y1. Wait, what?
Sorry, I don't understand what you did there. What's one?
So what I did was I called this line y1 in case I wanted to graph it. Now it's there for me. So now I don't have, I'm sorry? No, you don't have to do that. It's just something that makes life easy sometimes, because what we're going to do now, and by the way, my equation's gone, and I have a go back feature, so I'm going to fly through it real quick. I wish there was a way to go back to show you previous screens. That's the one thing the calculator doesn't do that I just absolutely wish it did.
Yeah, what a crappy calculator.
Oh yeah, $120 crappy calculator. Anyway, there we go. So remember, we're always rounding to 3 sig figs. So for our a value, technically it would be 0.04. Oh, excuse me. It would be 0.0402. This 0 right here is not a sig fig. First sig fig would be the first non-zero term. So to raise it to 3, to round it to 3 sig figs, this 7 makes this 1 a 2. And our b would be 18.1. And look at our R value, 0.992. That is ridiculously strong positive correlation, 0.992. It's probably going to be asked about. So our equation is, the length is generally found by having 0.0402. Ooh, I can do better, I promise. 402, board is lagging. W plus 18 point, it's actually 18.1, right? Remember, more sig figs is allowed, but not less. I think on mine I wrote 18.13 just because I like to have more decimals, but 3 sig figs is good. Now realize, because we cut off the slope decimals and the y-intercept decimals, we're not all going to get the same answer. And that's why IB is going to give you the range of acceptable values for answers. Normally, you'd be asked to use this equation. You'd be asked to plug in a value for W. And Max, that is why I would want to have that equation stored. Because if the equation is stored, and let's just say it wanted me to plug in the number 4, 5, something like that, rather than having to actually type in all the decimals, I can go to second table, and it will show me, if I scroll up to 5, what the y value is. I'm just saying, that would be why you want to do it, because table would help you get there. But it's not necessary. It's just a trick. And we're just going to do it again. And once we do it again, we're finished with the lesson. We're finished with the unit.
What is this formula you're using? That L equals.
Oh, this is just the equation for length and weight. It's just relating the two. We just use linear regression. If I had asked you to make a scatter plot and then said find me a line that models the data, this is its equation. Instead of saying y equals mx plus b.
How did you find that?
I used the calculator to find it. That was what we did. That's what linear regression means.
Oh.
Linear regression means give me a slope-intercept form that models this data.
That 18.1
Yeah, it gave me 18.1.
I just didn't see it.
It was 18.1. Yeah.
Okay. Well, I'm gonna do it.
Well, here. There it is. If I scroll over, you'll be able to see it.
Oh, I see it now.
Yeah, it wasn't on this screen that I saw it. It was on the previous screen that now you can't see anymore because there is no back feature. But we'll do it again. Now this one will actually use the model for something. This table shows how far a group of students live from school and how long it takes them to travel there each day. Well, part A says figure out what your R value is, and also the equation of the least squares regression line. That just means line of best fit. Nice thing is both of those answers are on the same screen. So at least that was nice of them to do. So stat, edit, let me clear these lists, and type these bad boys in again. Just be careful, make sure that you type them correct. Take your time, double check. Don't want to miss any decimals or, I don't know about you guys, like my calculator has a sticky key. Like one of them, when I type it, I feel it click, but it doesn't always type because my calculator's been used and abused for several years. So I'm very careful. I think it's my 6 key. What's that?
Kitty thought there was random people on the Zoom.
Oh, well, because Katie was late to class, so she doesn't know who's on Zoom. But Katie, those are my grandparents.
Hi.
She said hi. Katie, you feeling any better yet?
I feel better. It's just I feel great. It's just my throat.
Okay, well, warm tea and honey.
I don't think I have it though. I'm completely fine. I'll be back.
You have COVID?
Ooh.
Gavin's scared. He wants you to go get tested, he said.
No, like I found out that even if I get tested, no matter what my results, I still have to quarantine for 10 days. So I was just like, I'll just let it.
You know what? That's what students should do every time they get sick anyway. I mean, we are also, I mean, I think it's a cultural thing where we're all just used to working when we shouldn't. You know, like it somehow or another it became a thing. Like if you didn't work during your lunch period, you weren't a hard worker, and if you didn't give up your vacation time, you're not a hard worker, and things like that. And then, but the same thing happened to students. Like honestly, if you're sick and have a fever and things like that, the best thing you could do is stay home and sleep. You know, drink water, eat some healthy foods, and sleep. But instead, we go, no, I can't miss any school, and I understand why. You don't want to fall behind, but you get better faster if you stay home and rest. Oh, and that's right, you don't get me sick and have me take it home to my kids. So stay home, sickies. All right, so we've got our L1 and L2. I told me, he was jokingly last year. I told my wife, maybe even the year before, I was like, I think I'm going to start teaching with a mask on so I don't get sick anymore. And then, yeah, I did. I said it a couple years ago. Well, because I get tonsillitis almost every winter, and it's awful. And it's like, I'm tired of this crap. I'm just going to start teaching with a mask on. And no, you don't get your tonsils removed as an adult. It's weeks of like some of the most unbearable pain you've ever experienced, is what 2 different doctors told me. They're like, if you're going to do it, you do that as a child.
Well, you can get that. You can get a procedure that reduces the size of pores in your tonsils.
What?
So that they're least likely to get infected.
Okay, that's interesting. If it ever happens again, I'll mention that. So what are we doing? Stat, calc, linreg. L1, L2, no frequency. I won't even bother storing because we don't need to. We'll just write it by hand because we want to show our work in case we're wrong, right? So there, you got it now? So this one shows you your A and your B. The Y, A, and B is missing R and R squared because you don't have your stat diagnostics turned on, which is what I told you guys how to do yesterday. So when I finish with the lesson, I'll help you get your stat diagnostics turned back on because you need to be able to find that R value. I mean, that's the first question, right? So our R value this time to 3 sig figs is 0.993. And I'll just go ahead and write those 2 decimals down for our regression line. R is about 0.993. And then the equation equals 2. I went to 4 sig figs. 2.16 x plus 1.42. That's 3 sig figs. Now again, if you go more decimals, that's fine. Less decimals, that's a no-no. Part B. Pam. Pam lives 15 kilometers from school. Estimate how long it takes Pam to travel to school. So for BI, kilometers is a distance which is an x. So you just drop 15 in for x. Y equals 2. Try again. 2.16 times 15 plus 1.42. Showing that line right there would get you a mark. A student attempted to substitute into their equation. Even if your equation was wrong, you'd get a mark for showing that that's what you're supposed to do. And we should have gotten somewhere around 33.8. Yeah? Nobody's checking but me. Yeah, somewhere around 33.8 minutes. Is this minutes? It is minutes. Oh, Gavin's making noise. So the question says to estimate how long it takes Pam to travel to school. We got 33.8 minutes, and if you were trying to talk about whole minutes, let's say it was one of those questions that was like nearest minute. Basically, if they're asking for whole numbers and they don't specify, they don't say things like the least or the greatest or whatever, you just round to the nearest whole number. So about 34 minutes. About 34 minutes. So if it said estimate to the nearest minute, about 34 minutes.
And if it didn't say it,
If it didn't say it, then you would say 33.8. Question B double I says to comment on the reliability of our estimate. Well, what do we think? Is this a reliable estimate?
no.
Two people say yes, some people say no. Yeah, so we have an R value of 0.993, so this is highly correlated data. And more than that, it's interpolation because 15 is well within the range of our X values. Our X values range from 1.3 all the way up to 23.5. So since it is interpolation and our R value is a strong R value, this is a reliable estimation. So we just basically write that in words. So if on your test it says to comment on the reliability, you need to be using words. So I wrote since, and I used one of the known intervals. Remember, oops, I forgot. Remember, you're not required to memorize these. So they would be given to you usually if you had to use them, but I'm just going to go ahead and use it. So since R is between those two values, our data has a strong positive correlation. We have a strong positive correlation. Correlation only has one L, right? Okay, I can't spell. And since we are interpolating, which is a word, our estimate is reliable. And notes have come to a close, unless, of course, we have any questions.
So we're interpolating, like, as in, like, we can see that on the.
So interpolating means that the X value that we plugged in, our 15, was within the range of X values. So as long as it falls between the smallest and largest X value, you were allowed to plug it in because you're interpolating. Now, if it was, let's just say you plugged in the number 25. Even though this thing is highly correlated, technically you would need to say that that would not be a reliable estimate because X equals 25 is outside our range of X values. So that's extrapolation, and generally extrapolation is not acceptable as a reliable tool.
Yeah.
And the other thing which we didn't do in today's notes, what we did do in yesterday's notes is if we could have used a Y value to predict an X value, but the old curriculum says that that is considered unreliable because it is not linear regression of Y on X. That's not what we did. We did X on Y. Again, I still have to ask the other stats teachers what their opinion is at this point, but that is it. And we can stop recording the notes.